Okay, welcome to join this class. This class is because this class is a EMI class, so the academic affair office each class have to use this software to record all of the material, course material. So and the room in that room is the computer just got the virus, so we have to temporarily move to here, and then the computer, the center, they will send people to install the software there. So maybe the next class we will move back to there. Okay. And the first thing I would like to ask, create a line group. So if anyone you want to select this course, and then please join the line group so we can share the information, all of the information. And if you have any question, you can use the line group to ask me, okay? Or even assignment and the test, I will use the line group to post the question on the line group. So. Okay, and this is the first thing, the most important. You need to join this line group. And the second thing is you have to download an app, because you will always check there are some statistic data. So you need to download an app, the statistic app. I will recommend software called probability distribution. Probability distribution. So you can go to the probability distribution. There's a FX, the symbol here. You can go to the Google Play, or it should have a rate, color, a software called the probability. Let me see if I can find here. How? I cannot find it from here. So I will show you it look like. 红色的有一个 FX 的那个，this one? Yeah, this one. This one. This app. This one. This one. Oh, sorry. This one.有一个红色的那个 FX 的。Later on, we will make a brief review regarding to the basic concept of the statistics. We will also use this app, and then you have to familiar with how to use this app, because in the following course material, we will always check the F value. And the T value, Z value, and so on, and to check their probability. So you have better download this app. And this course, well, since this is the statistic related, so according to my experience, the most effective way to learn this kind of the course is I use the whiteboard. I use the whiteboard and then derive the equation step by step. And also, I used Excel. I give you some example, because in the class we will use Excel, try to solve lots of the example. And during the example, of course, all of the example will follow the material I present in the whiteboard. And then, so I will suggest you to do the note, because I will not provide you the PPT file, because actually I have the PPT file, but if I give you all of them, then you will just sit there and then you will get fall asleep. And that's not a good way. So according to my experience, the best way is still if you can take a note by yourself, even you don't understand at that time, but going back, if you discuss with your classmates, and then later on maybe you will understand, and then you can rewrite the and hand out by yourself, use your own language, to that yourself you can understand your the material. So that's the best way to learn the mathematical related subject. So I will not provide you the PPT file. So you have better either you can take a picture and then go back to write by yourself, or you can take a note by yourself. Because in the past, because the design of this classroom is not good. Actually, my perfect is the projects in this side, and then this is a big whiteboard or blackboard. I can derive the equation and then step by step to show you why what's the theoretical background regarding to the all of the theory. And then after you got the basic background regarding to the statistic background, and then I will use the Excel to use some example. I will show you step by step to show you, okay, how to use Excel to calculate those factor analysis and principal analysis and so on. So regression analysis. So those are the way I am going to teach you. Most of it I will use the of course, because in the beginning, in the earlier years, when I first time to teach this course, I used the whiteboard. But the problem is the whiteboard is too small, and then this is you see the color is very light. So maybe in the back of the student you cannot see what I wrote, and then sometimes this is too small. If I wrote too small, then you cannot see it. If I wrote too big, that's not big enough to write all of the information in the whiteboard. So that's the problem. So later on, I prepared the PPT file and then project on the screen. Then I think this way most of you can see the material. So that's the compromise. After several years experience, so I found this way is maybe the most effective ways to teach you this course. But I still encourage you to write a note by yourself. Okay, and this course we will cover from some hypothesis test. I assume you already have the basic knowledge regarding to the statistics. Of course, today I will make a very quick review regarding the most important concept we will use in the following teaching material. So after that, we will cover the very basics t-test, the independent t-test, pairwise t-test, ANOVA analysis, and then we will move to the single regression or simple regression and the multiple regression. After we discuss the regression, I think we will move to the PCA, principal component analysis. And of course, the PCA is also a factor analysis. It can be easily applied. Use the PCA became the factor analysis. After we discuss the factor analysis, I think we will cover discriminant analysis. And then, of course, the discriminant analysis, after we finish the discriminant analysis, I will give you a midterm test. And the midterm test will cover the material which I just mentioned. It will include the t-test, ANOVA analysis, and regression analysis, PCA analysis, and principal factor analysis, also the discriminant analysis. So all of this material can be solved using Excel. You don't need any advanced software, but to solve it. All of this I just mentioned, you can just use Excel to solve. Of course, some of the subject, the Excel also provides a very good answer, but in the test, you still need to use Excel step by step. Of course, you can use the built-in function to use and then try to find the answer. But when you in the midterm test, I still ask you to follow the step which I teach in the class, step by step to solve the equation. You cannot use the built-in equation in the Excel. Otherwise, you got 0. Because the most important is I want to know what's the theoretical background regarding to this calculation. Not just use the software and then pop in, pop out, and then you know nothing. You know, that's not a good way to understand those tools. So that's and the time will be around. Usually based on the previous years, the time will be at around end of November and earlier of the December. And also I know some of the student is a PhD student. Is there anyone will take the qualified exam in this semester? Can you raise your hand? 就是这个礼拜这学期要考 qualified 的有没有？请举手。没有吗？ next semester. Okay. If no, that's good, because sometimes it will conflict with your qualified exam, because the midterm test will be usually at the end of the December or the earlier of the end of November or earlier of December, but so it will be almost the same time as some PhD student. You will take the qualified exam, but because you need to spend lots of time and effort to learn these methods. So I'm try to avoid for those students if you have a conflict of time. Okay, so that's the midterm test, and also we have a final exam. There is a handwriting test. But in the handwriting test, in the midterm test, you have to bring your notebook. Okay, you have to bring your notebook, and then with of course with the Excel. So you need to use the Excel. Try to solve all of the I just mentioned those technique or those methods. And then after the midterm, then we will move to the cluster analysis. We will move to the cluster analysis. Because the cluster analysis, we need to do the iteration. But use the Excel, we cannot, except you write a VBA program, and then maybe you do the iteration. But that's too complicated, because some of you do not have the background regarding to write a code. So in that time, in that part, I will only introduce the basic concept of the cluster analysis. What's the logic, k-means, hierarchies, cluster analysis. And then after that, I think we will move to the SEM, the structural equation modeling. And the structural equation modeling is most advanced application in the advanced statistics. There are lots of in the management science, they use the statistic, the structural equation modeling. The structural equation modeling, there are many software we can use for the structural equation modeling, but in the recent year, the most popular way is use AMOS, A-M-O-S, AMOS. We have the AMOS software, and also for the cluster analysis, you can use the very famous software called SPSS. both the AMOS and the SPSS, they have the our school we have the web-based version, but the web-based version is lots of trouble because you need to learn that how to interface with those web-based software. But if you have the old version of the AMOS or old version of the SPS is still working, then I will encourage you use those old version of the status. We don't need to be the latest version of the SPSS or AMOS, and so that's the in the final. After I think from December, late of December, we will start move to the SPSS and the AMOS this software. And if you are not familiar with those methods, maybe you can go to the NTUT Cloud 北科云，我不知道那叫什么，北科云就是 is a cloud. There are lots of software our school purchase is the web-based software. So you can go there and then try to learn how to upload the file to there, and then how to download the file from the 北科云. Okay, it's not convenient, in the past few years, there are lots of choice, especially if there are too many students logged in the, then, it became very, very slow. So it's not convenient. So if you have the old version of the SPSS or AMOS, I will encourage you install in your computer, because that will be faster and easier to learn. And also, we are not use a very advanced AMOS or SPS. We are just use the basic concept of the SPS and AMOS. So the old version should be enough for your application and also solve the problem. So that's the midterm and the final exam. Also, I will give you some assignment during the class for each subject. I will give you assignment, and those assignments will be very, very similar to the in-class example. So the in-class example, actually, I just changed the data. So because the in-class example, maybe if you have a problem, then you can discuss with the classmate, and then you can take time to think about it. So, but I still encourage you go back to try to solve the assignment by yourself. Do not ask somebody. Try to solve it, because if you do not try to solve it, you will get a trouble when you have the in the midterm test, because because in class example or exercise, you can discuss with your classmate, and then, but in the midterm test you cannot. Of course, that's a test, so you cannot ask somebody. You have to solve it by yourself. But all the steps and the logic are the same as the in-class example. So the assignment I will ask you to do. So you have better do those assignments by yourself. Do not try to copy someone's file, direct upload to the system. So the system we will use is iPlus system. That's also developed by NTUT. So later on, I will after you finish your assignment, you have to learn how to upload your assignment to the iPlus system. Okay, so that's the regarding to the assignment. Also, I will randomly check the attendance, because in case in the end of the semester, the percentage usually is usually the final exam will occupy maybe 50%, and midterm is 40%, and then the other 10% is your attendance and your in-class environment. Okay, so that's 10%. So usually the most important is your midterm test and your final exams. And usually, most of students you can get the 10% attend because since you are the graduate student, it's supposed the graduate student, except you have some maybe the part-time student, you might have some business trip, then you can tell me in advance. Otherwise, I'm supposed if you are the full-time student, you're supposed to attend the class every time. So for most of the students, you should have got the 10 points, the attendance score, and then the others are the midterm test and final exam. And the final exam, you cannot have your computer. You have to solve it by hand calculation. And you can bring the calculator, of course. You can bring the calculator, but you cannot bring the cellular phone in the final exam, because the cellular phone you can take picture and send and exchange the answer with somebody. So in a final exam, you cannot use your the cellular phone. So it will be only you can have a A4 size of the blank paper. You can write everything, any equation or any note you want to write in that paper, A4 size paper, and then you can write everything in this paper. All of the equations, because there are lots of the equations in this semester. Maybe those equations is not easy to memorize, so you can write all. Except that one, you can bring. There's no transmit function. Your calculator, the calculator. So you can have a calculator, and then you can have a A4 size of the sheet, and then this paper, that paper, you can write everything on that paper. And because most of those programs are concept problems, so it's supposed, if your concept is correct, then if you do not, but you still need to familiar with how to use the calculator. Otherwise, it's maybe not enough time to that you finish the exam or final exam. Of course, I will provide last year's final exam to that you make practice, and then you are familiar with what the final exam will look like. Okay, so you can prepare it in advance. Okay, so that's regarding to the final exam. And what else you need to know? Any question? Maybe I forgot some very important information. Class material? Well, there's any textbook regarding to the multivariance analysis. So there are lots of textbooks, but one of them is if I do not, I have a Chinese version textbook. Is maybe you can. But I do not have the English. Maybe you can check the English textbook. One of the books when I learned this multivariance, I read his book. I forgot the name of the textbook. He has two books. One is the multivariance. Another one is the structural equation modeling. So both of them is you can if you would like to read material, maybe you can see this guy's textbook. And also there are some English textbook regarding the multivariance analysis. So, but I do not specify any textbook. So all of the material would be, I have a concentrate and then mix all of the lots of the material and then put in my class handout. So if you understand all of the equation I show up in the whiteboard or the screen, it should be enough for you solve all of the problem. Okay, so any other question? And what else? Oh, there's another very important. I would like to say apologize for you is because the next week, the same time, our VIP guests from United States, UT Arlington, the president and their vice president and their vice provost, and then there are some, there are one chairman. They will visit our school, and then I am responsible for receiving those VIP guests. So I will not be here. So, and also I know to find another alternative time to fit everybody is almost impossible. So that's impossible because you know, especially some students, you have a part-time job, and then or even a full-time job, and then so it's almost impossible to find alternative way to make up those missing courses. So next week we will have no class. So please don't come next week because I need to go accompany and receive our VIP guests from United States, and then I will bring them to our go around with our campus, and then also meet our president, and then also have them internal meeting with them because they are our sister university. So if, of course, if you are interested to the foreign exchange, you can apply this university, the UT Arlington, University of Texas at Arlington. Arlington is in the Dallas, actually in the Dallas and Fort Worth city. And then this is of course, the UT system. There are many campus, different campus. The most famous, of course, is the UT Austin, and then this is the second one, UT Arlington. Also, they have a UT Dallas and the UT San Antonio. UT maybe I'm not sure if the Houston they have the branch, or they have the campus. I'm not sure. Another one, UT. Except the UT system, they have another system is the Texas A&M system. There's another UT system. Texas, they have two major public university systems. So if you are interested in the foreign exchange, then maybe because they are also our sister university. So you can apply the dual degree. I remember one of our very many years ago, he applied a dual degree, one master degree here and another master degree from UT Arlington. Okay, so that's the next week we will not have a class here. So is there any other question? Okay, if you do not have any question right now, maybe you can ask me anytime during the break, or use the line, text me. Both of way is okay. And okay, if you if you do not have the answer, we will start to make a very brief review regarding some very important concept we will you will need in this class. And the first one, since the reason we learned this advanced application of advanced statistics, because there are lots of the data right now. You can see, especially the big data era right now. You can see everywhere is the data. There are lots of sensors collect lots of data. And for those data, how to analyze them? Of course, the very traditional way is use the statistics. Even some of statistics is maybe developed very old, but they are still very useful. Especially if you are those, just you can based on this linear assumption, and then you can get some preliminary very good result. But of course, right now the mainstream is used some nonlinear methods, such as the most famous is the neural network. But neural network, of course, I was encouraging you to take the course neural network, because that's the very powerful tool to solve the nonlinear problem, the neural network. And this is the advanced statistics is the very useful for linear problem. If your problem trying to solve is linearly, then also there are some many similar concepts you can apply from this linear transfer to the nonlinear. And then, except the neural network, of course, there are many other nonlinear, like SVM, support vector machine, genetic algorithm, and then there are lots of the algorithm to try to solve those nonlinear problems. But but the traditional way statistics is still very important concept and the background and also the foundation for you learn some nonlinear problem. Okay. So the data type, we have the four major data type. The first type is called nominal scale. The nominal scale is such as the name, gender, blood type. For those of the data, you cannot rank them. You can just distinguish, okay, this is a boy, or this is a girl, or this is the blood type A, this is blood type B, or I'm blood type O, and then he's a blood type AB, and then whatever. For those kind of, you can just distinguish them, but you cannot rank them. You cannot rank. It means you cannot make comparison between two groups. Okay, you cannot say the man is better than female. Female is better than male. Okay, so you cannot make this kind of direction. Or you cannot say, okay, the white skin is better than the yellow skin, and the white hair is better than the brown hair. Well, you cannot make this kind of comparison. So that's the nominal scale. So the typical is like the name, gender, blood type, occupation. You cannot say this occupation is better than that occupation. So you cannot make, or your living place. He lived in Taipei, he lived in Kaohsiung, he lived in Taichung, Hualien, Taitung. You cannot say I live in Taipei, I'm Tianlongguo, so I'm better than you. No, you cannot make this kind of derivation. Okay, so that's the nominal scale. You only can distinguish them. Okay, the second type of is called the ordering scale. For those kind of data, such as the satisfaction level, okay, this is very typical. The very satisfaction, or the very good, medium, poor, very poor. So those kind of scale is very, very common in the social science. Whenever you go to the restaurant, right, you go to Wang Ping Niu Pai, then or any restaurant, they will, after you finish the dinner, then they will give you a survey. Okay, you will check how did you feel today's the meal is good, medium, very good, and then how did you think about our today's the waiter's service is good or bad or whatever. Okay, so those kind of the scale is, we call that ordering scale. So you can rank in them, but you cannot you cannot make a derivation. Say, okay, the very good is even we are usually use the very good is 5 point, good is 4 point, and medium is 3 point, and the poor is 2 point, very poor is 1 point. But you cannot say, based on this order, you cannot say the very good is 5 times of very poor. You cannot say this kind of derivation, because the 1, 2, 3, 4, 5 is just you based on this order, you give them aside the number. But you can also say, okay, the very good, I would like to say very good is 10 point, goods is 6 point or 7 point, and then and the medium is 0.4, and the very poor is 0.3, and so it's not to be 1, 2, 3, 4. You can assign any other number. It's not to be the same range between each scale. So that's the ordering scale. So you can ranking them. And another scale is called another kind of data. It's called interval scale. The interval scale is you can add it, but you cannot. You can add and subtract it, but you cannot multiply them and divide by them. So the typical data is temperature, because the temperature today is maybe according to the weather forecast. Today's maybe highest or maybe is 38. So we can say, and if yesterday the highest temperature is 36, we can say today our temperature will be 2 degrees Celsius more than yesterday. That makes sense. Okay, so it can be added, and then maybe tomorrow we will drop a 10 degree. Maybe you should, okay, tomorrow's the highest temperature will be 10 degree less than today's highest temperature. So it can be added and subtracted. But the zero is not really zero. That means the temperature zero is not really zero, because the temperature zero means no temperature. No, right? Temperature, the degree of the zero is still have some temperature. Right? That's a relative. You set that point is a zero, but actually in that point it still has some degree or some temperature there, right? So that's the interval scale. And for engineering, they prefer the ratio scale, okay, or the interval scale. The ratio scale you can add it, minus, multiply, and divide it. And the zero is really zero, because the typical scale is like the high weight length. If your weight is zero, then it means no weight, right? And if the length is zero, it means no length. But the temperature zero is not means no temperature. So that's the difference. So for those kind of scale, for those kind of data, we call it a ratio scale. For engineering, most of they collect the data is belong to the interval scale and the ratio scale. And that's for the engineering, because they will collect the length, weight, acceleration, and gravity, and temperature, and so on. So the vibration, so those are typical data they would like to collect. But for the social science, lots of data is for these ways and these ways. Okay, just like we collect lots of the what's your some data. Okay, your satisfaction level and the each response, or your gender and your different education level, different occupation, different location. And we use this kind of survey to try to get some service level. So that's the difference between these 4 typical data. And then after we define the data, then we usually face a lot of the data, a lot of the data, and is there any number we can represent this whole set of data? Is any number we can represent those whole set of data? The typical one will be which one? Average, right? Average. Average will be the most typical. This cannot move. The average is most typical data, most typical variable to represent a set of data. What's their concentration trend? Well, except the average, is there any other variable can represent their concentration, the trend of concentration? Can you list some of the similar variable except the average? Chris? Yeah, median, good. Median, 中位数. Median is also a very typical variable, can represent the concentration, okay? Except the median, and there's also another mode. Mode, 众数. 众是大众的众，众数也是就是集中趋势量 okay? So those are typical variable to represent a set of data. What's their trend to concentration? And except the average. For example, if this a set of data A, a set of data B, for A and B, okay, the average is 80, right? The average is also 80, right? This is very obvious. But these two sets of data, they represent the same situation? No, right? This is, all of them are equal to 80. But this, they are various. But although their average is still the 80, but there are different distribution. So except the concentration trend, we also need a variable to measure their separation, degree of separation. So to measure their degree of separation, we can use some number of variables. The most popular way is to use the variance. The variance, the concept of the variance is that we calculate all of the data with their average and then take the summation. So is the if we take the summation. So it means that if we take the and then divide by number of n. So what happened if we subtract the deviation for each number with respect to their average and then take the summation, what happened here? It will be equal to 0, right? Of course, because there are some number is less than 80, there are some number is larger than 80. So if we use this way to measure their separation degree, then it will become 0. So this is to avoid become 0. Maybe we can do it is take the absolute value, right? We can take the absolute value. So it will avoid to that then equal to 0. This situation happened. But to use the absolute value, this is not convenient when you do the calculation. Because when you do the calculation, if you need to judge if this is positive or negative, and then it will take time. So it's not easy to calculate. So another way is to avoid the positive and negative problem here. So maybe we can take square, right? We can direct take square and then take average. So we will define this as the variance, right? So we will define this as a variance. If this is, and then we take the how many of this data and then divide by, if this is sample data, we will divide by n-1. And that's usually the data is a sampling data. We are not a whole population, so we have to divide by n-1. But why we divide by n-1, not n? This you can go back to see lots of the statistic textbook. They have the proof why when the data is sampling data, you need to divide by n-1. So after we define this as a variance. This is the variance. But since we take the square, so the original union will become the square. So we had to return it back to our original union. So we can, we were take the square roots. We will take the square roots to that then became the same union. So it will become, we call this a standard deviation. So this is the definition of a standard deviation. So the purpose, why not we use the variance, is because we try to that the union is same as the original union. Otherwise, if the original union is the centimeter, and then you take the square, it became the square of centimeter. So it became the area. So the union will be different, will change. So we take the square. That's the way. And okay, the standardized, because for each normal distribution, and then let's move to there and continue. Okay. Okay. Let's take a break and then move back to that room. I think you stay here. I will go there to check if they finish the installation. If they finish, then we will move. And if not, then we still need to stay here. Or take a 10 minutes break. Okay.